Hi everyone and welcome back to my YouTube channel. Today we are doing past paper questions on bearings, CSEC Math paper 2 past papers on bearings. We are starting from the 2022 paper all the way back down to 2018. Be sure to remember to click that notification bell below this video so you will always be notified when we are going live. Subscribe to my YouTube channel and be sure to click a thumbs up before you continue. Here we are starting with the May-June 2022 question 9 part B. From a port L, ship R is 250 kilometers on a bearing of 65 degrees. So they already gave us our diagram. They said from a port L, so this is L, ship R is 250 kilometers on a bearing of 65 degrees. So it's from L to R, okay? So wherever it's from is where you are starting. So from here, we have a bearing of 65 degrees. Ship T is 180 kilometers from L. So ship T is 180 kilometers from L on a bearing of 148 degrees, right? So let me read that again. So ship T is 180 kilometers from L. So T from L on a bearing of 148 degrees. So they said from L, so wherever they say from, that's where we are starting. So it's from L to T, they are making a bearing of 148 degrees. So this entire thing here, all the way down to T, the total bearing is 148 degrees. All right, so we can leave that there, or we can immediately see that this entire angle is 148 degrees, and this little angle here is 65 degrees. If this angle is 65, but the entire angle is 148, we can clearly find this missing angle right here. This whole thing is 148, and this portion is 65. So the remainder, which is this little angle here, is going to be 148 degrees, take away 65 degrees. And that will give you a total of 83 degrees. So I am now going to proceed to erase this 148 so we can clearly see the angles that we have on our diagram. All right. Now, this information is illustrated in the diagram below. Insert angle RLT. So this means that the angle is at L. The angle is always in the middle letter. Okay. So part 1, they want us to find RLT. It can be written like this, or they can write it as this, angle RLT. So these two things mean the same thing. So it's RLT. The angle is formed at L, and we already calculated it to be 83 degrees. How we got that again? This is total angle, they said was 148 degrees. We subtracted the 65 to get 83. So 148 degrees take away 65 degrees is equal to 83 degrees. Now these solutions I'm giving you here, they are just the solutions, and I am explaining how we get it. But if you need some step-by-step guidance on how to actually work out trigonometric questions like these, you can simply click the link below and you'll be on your way. Question 2, they said calculate RT, right? So RT, so basically this distance they want us to calculate, right? Calculate RT, the distance between the two ships. Now, usually more than 98% of the times, whenever you have to calculate the distance in this form, and it's a bearings question, you have to use the cosine rule. I always tell my students, once you have two sides, and of course you'll be trying to find for one, so that's 1, 2, 3 sides and an angle, you are going to use the cosine rule. It becomes a little tricky sometimes, and students are unaware of which rule to use, whether it be the cosine rule or the sine rule. right? So we're going to find this side. We have two other sides. So that's 1, 2, 3 sides we are using. And we have an angle given. So it's the cosine rule. If we had other angles and according to how the question was asked, we could have used the sine rule. We have other questions coming up like that. So stay tuned. All right. So the cosine rule now, we are trying to find RT. So RT is the side we want to find. So RT squared is equal to, you are going to square these two sides and sum it, right? So that's 250 squared plus 180 squared. And we are going to subtract 2 multiplied by these same two values, all right? Cosine of the angle that's opposite to this length. So this length here is RT, the angle that's opposite to it is 83. You simply put all that in your calculator, just like that. We're not going to waste any time in the exam. You put all that into your scientific calculator, and the value you are going to get is 83931.75909. 83931.75909. All right, so therefore RT is equal to the square root of this long answer. If you are really good in your calculator, you can just say square root of the previous answer. You're good to go. You skip a line there by doing that. And this gives you a total for the length of RT to one decimal place being 289.7 kilometers. All right. Again, I'm just doing these solutions. If you need help in how to use the cosine rule, how to do these types of questions, step-by-step guidance from basic, you know what to do, click the link below and I'll help you out. So now we're on part 3 of the question. It said, determine the bearing of T from R. So remember, from is where it starts. So the bearing of T from R, of T from, look, R is here. So of T from R. So we are starting at R. Of course, it's the bearing. So you have to draw your cardinal point, the North Pole. All right. So it's from R and we are going to T. So from the North Pole, you're going all the way to the line that says T. This is the line here that goes to T. So we want to find this angle. Okay, now we know that this angle here and this angle here adds up to 180 degrees. So let's put that missing angle. So this angle here that we're going to insert, 65 degrees plus this angle adds up to 180. So we can simply say 180 take away 65 degrees to get this missing angle. And that will be 65 degrees. Okay, these two angles here add up to 180 degrees. So we are now on part 3. Part 3 said determine the bearing of T from R, right? So it's from R, the bearing of T from R. So we are starting at R. So wherever we are starting, to find the bearing, you have to put your cardinal point, you put the North Pole. So we are starting at R, and we are going to go all the way to T. As you can see, this line connects us to T. So this here is the angle that we want to find. Now, this angle here and this angle here adds up to 180 degrees. So if these two angles add up to 180, to find this missing angle, it's simply 180 degrees take away 65 degrees. 180 degrees take away 65 degrees will give us 115 degrees, right? Now we know that the total amount of degrees in a circle is 360. Now, if we could find this missing angle here, we can simply add 115 to this angle and subtract it from 360 degrees to get our bearing, right? Now, how we have to find this missing angle here, we look to see if we have any type of alternate angles, right? As the first thing we tend to look for. And if you do that, you'll notice we are not seeing any type of alternate angles. So our next option is to use the sine rule. All right. And for CSEC, most questions are written like that. To find the missing side, you use the cosine rule, and to find the missing angle, you use the sine rule. I'm not saying it's hard set, that's it all the time, but for the last couple of years, that's how it has been, okay? All right, so we are going to attempt to find this missing angle here at R. So the sine rule says the length divided by sine of the angle that's opposite to that length, all right, is equal to the another length of the same triangle divided by sine of the angle opposite to that length. Now we just calculated RT to be 289.7, so I'm just going to write that down. 289.7. It's always good to write down, like every time you work out something, when you are doing questions like these, you insert it in your diagram so you know what you have, okay? All right, so let's start it. So we have the length, which is 180 degrees, divided by sine of the angle that's opposite. I'm just going to label that angle R because it's at R, okay? Instead of writing the whole angle LRT, I'll just write an R, okay? Is equal to the next length, 289.7 divided by sine of the angle that's opposite to that length, which is 83. Right? Now we could not have used this side because we don't know this angle. If we had used this side, it would have been 250 divided by sine of the angle opposite to this length, and we don't know this angle. So that's why we had to use the 289.7, which we previously calculated. All right, so this is basic algebra. You could simplify this immediately and then cross multiply, or you can cross multiply one time, whatever suits you. You can do it how you are accustomed to doing it once it's algebraically correct. All right, so let's cross multiply. So cross multiply, and we have 180 multiplied by sine 83 is equal to 289.7 multiplied by sine R. We are making R the subject of the formula. So sine R is equal to everything we have on the side divided by 289.7. This whole thing, everything here, is divided by 289.7. And we are now going to find for R. So therefore, when you bring across this sign, it becomes sine inverse. I'm just going to write it on top here. So R is equal to sine inverse of everything we wrote just now, which is 180 sine 83 all over 289.7, right? When you plug all of that into your calculator, make sure your calculator is in degree mode, you are going to get 38.1 degrees. If you want me to do a calculator session, just type that in the comments below and we will do something for you. All right. So this angle here, we just worked it out to be 38.1 degrees. Now remember, our ultimate goal was to determine the bearing of R from T, okay? So it was this angle here we wanted to calculate, the bearing of R from T. So let me just change the color since the board has a lot of writing. So to get this missing angle, we know these two angles plus this angle here makes up 360 degrees. So you simply take 360, subtract these two angles, and we will get our missing angle. All right, so I'm just writing it on top here. So you simply take your 360 degrees and you are going to subtract these two angles, which is 115 degrees plus our 38.1 degrees. All right. When you do that, you will get 206.9 degrees. So the bearing of T from R is simply 206.9 degrees, all right? So we are finished with the May-June 2022 paper question 9B. Moving on now to the January 2022 question 9B. Again, we are still on bearings, okay? So our first question, the first question said that the diagram below shows straight roads connecting towns L, M, N, and R. Okay, so it's L, M, N, and R. LR is 18 degrees. So where's LR? Well, 18 kilometers, sorry. LN is 12 kilometers. Where is N? N is 12 kilometers. MN is 10 kilometers. MN is 10 kilometers and angle RLN is 25 degrees. Angle RLM is 25 degrees. Let's put that in. Angle, oh, it's in already. RLM, but N, sorry, is 25 degrees. The angle LMN is 88 degrees, and they put that for us. So they just rewrote, this entire diagram and everything they put it here for us. If you need access to some past papers, you just type that in the chat and I'll give you the link to get past papers for free, okay? Now, the first one they said, calculate the angle MLN. So that's MLN. The angle is made at the middle letter, okay? So they want us to calculate this angle here. MLN. They want us to calculate this angle here, okay? Now, if you notice, this is not a right angle triangle, so we cannot use SOHCAHTOA 12, all right? This is not a 90 degrees. If it was 90 degrees, we could have subtracted the 50 to get this missing angle, okay? So our next option, knowing that there are no alternate angles at this moment, we can use the sine rule to get this missing angle, okay? So it's the length divided by sine of the angle is equal to the length divided by sine of the angle. So the length is 10, all right? So we are on part 1. So the length of the triangle is 10, and you are dividing by sine of the angle that's opposite to the length, okay? So we can call it L because that's where it is at. You can call it anything you want. You can call it X, all right? Once you get your correct answer. Now we have 12, the length of the next side, divided by sine of the angle that's opposite, which is 88 degrees. Now, in the previous question, I told you you could work this out one time. So you can put this in a calculator and you'll get 10 divided by sine L is equal to the answer, okay? But for consistency's sake, I'm going to continue what I was doing. We're going to cross multiply. 10 multiplied by sine 88, all right? So 10 multiplied by sine 88 is equal to 12 multiplied by sine L. If I am talking too fast, below this video, you can alter the speed at which the video is being played for you. All right, so now sine L is equal to 10 sine 88 divided by 12. And L, which is the angle we're going to find, is equal to sine inverse of this entire thing. 10 sine 88 divided by 12. You put all that in your calculator and you're going to get 56.4 degrees. So this angle here that we were working out is 56.4 degrees, right? And which is what the angle they wanted us to calculate, MLN. So the angle here is 56.4 degrees. Part 2, calculate the distance NR. Okay, so where is it? NR. Remember what I said, whenever they want you to find a missing angle, once you cannot use alternate angles or any rule, it's usually the sine rule, which is what was done for part 1. And whenever they ask you to find a missing side, most cases you have to use the cosine rule. So look at this triangle. We cannot use the sine rule here because we don't have 2 angles. We only have 1 angle and we need to find this length. So we're going to use the sine rule. So I'll do part 2 on top here, right? So the cosine rule. We're going to use the cosine rule, right? So it's the side we want to find, squaring that is equal to the other 2 sides squared, but you have to sum that as well. So that's 12 squared plus 18 squared, and you are minusing 2 times these numbers here. It doesn't matter the order in which you place these numbers, okay? And then it's cosine or cos of the angle opposite to the side. It's NR we put here. So the angle opposite to the side is 25. So it's cos of 25 degrees. Again, you put all that into your calculator. You can do it step by step and put 12 squared and you work that out. And you work out your 18 squared and you put that, you know, You can do that. That's cool too. But if you put all this in your calculator, you're gonna get 76.47 5036. I put a lot of decimals so I can get my answer more exact. And R is equal to the square root of all of that on 4. So NR is equal to 8.7 kilometers, right? So that's the one decimal place. So we got 8.7 kilometers. Part 3 now, determine the bearing of town R from town L. Determine the bearing of town R. So let's change the color for part 3. Yeah, so determine the bearing of town R from town L. So whereas L, this is L, so we are starting at L and we are going all the way down to R. Well, we see is 1 mark, so that should be an easy thing. So we're starting at L and we're going all the way down to R. So we want to get that angle. But if you notice, we have everything already. They gave us this 50 degrees. We worked out 54.4 and they gave us 25. So you simply add all of them together to get this entire angle. So the answer is 50 degrees plus 56.4 degrees plus 25 degrees. When you add all of that, you're going to get 131.4 degrees. Easy. All right, that question was 5 marks in total. Question 9B. Again, remember, I am just doing these solutions. I am not really teaching. All right. We do past paper questions after the topic is being taught. So if you need help, you simply click the link below this video and I will help you. Okay. So we are continuing. We are now on the May-June 2021 question 3A. All right. Let's go back there. Now, this question is not a bearing question, but I'll still do it. So the diagram below shows the triangle PQR. All right, so we have P, Q, and R, in which angle QPR is 62 degrees, angle QPR is 62 degrees, PQR is 90 degrees, and PR is 11 centimeters. They want us to calculate the angle or the size of the angle PRQ. So the angle will be at the middle letter, right? So PRQ, they want us to find this angle. Now in the bearings questions, those questions, the triangles were not right angle triangles. So we use the sine rule and the cosine rule. But in the case where your triangle is not a right angle, well, in the case where your triangle is a right angle, I should say, you can use SOHCAHTOA to determine your missing angle. So this is the angle we want to find. Now, actually, we can just use all the angles in a triangle adds up to 180 degrees because we have 62, we have 90, and we're just missing theta. All right, so we don't have to do all that SOHCAHTOA thing. So all angles, right? So all angles in a triangle add up to 180 degrees. So therefore, PRQ, that angle, is simply 180 degrees. Take away the sum of the other two interior angles. So that's 62 degrees plus 90 degrees. When you subtract that, you're going to get 28 degrees. Okay, so let's just put in that in the triangle one time in case we need it. Lower down. So once you work it out, you put it in case you need it again. Part 2, they want us to calculate the length of the side RQ. Where is that? RQ. So they want us to find the length of this side. Now, to find the length of a right angle triangle, you can use Pythagoras' theorem, but we don't have this length, so we cannot use Pythagoras' theorem. So our next option will be one of the trigonometric ratios, SOHCAHTOA, right? So let's see. We have hypotenuse, and we want to find, well, this side is the opposite, so therefore this missing side is the adjacent. So we're going to use cosine. So cos theta is equal to adjacent over hypotenuse. So cos of 28 is equal to the adjacent, which is what we want to find, RQ. So let's put it as RQ, divided by the hypotenuse, which is 11. You simply cross multiply, and you will get 11 cos 28 is equal to RQ. You simply put that in your calculator and you'll be on your way. All right? Yeah. When you put that in your calculator, you're gonna get a whooping 9.75 centimeters. So that was quite an easy question. So we are going to move on. We are now on, let's see, the May-June 2021 question 9 part B. Okay. From a harbor H, the bearing of two ships Q and R are 69 and 151x respectively. So from H, right? The bearing of two ships Q and R are 69 degrees and the other one to R is 151 degrees respectively. Q is 175 kilometers from H. So Q is 175 kilometers from H, while R is 242. Ooh, that's on the side. R is 242 kilometers from H. Part 1 of the question said, complete the diagram and show the information given. And well, voila, that's what we just did. Okay, now I am going to put in a little extra information one time. Now this entire thing is 151 and this angle here is 69. So to get this missing angle, if the whole thing is 151 and we know that here is 69 degrees, we could simply say 151 take away 69 degrees to get this missing angle. So I'm going to put that in one time. So when we are working out our question, our life will be easier one time. Okay, so this missing angle here is simply 151 degrees take away 69 degrees. All right, so let's just double check what that is. 151 take away 69 gives us 82 degrees. So this angle inside of here is 82 degrees, right? Now part 2, calculate QR. So they want us to find QR. And we know from the previous questions, when you have to find a missing length, it's use the cosine rule, right? Most cases it's the cosine rule, and it is because QR squared is equal to the sum of the square of these two sides minus 2 times these two sides cosine of the angle opposite to this length, which is 82. Okay, so we are on part 2 using the cosine rule. If you all need like some guidance on the cosine rule, you can put that in the chat, in the comments below. Let me know, right? So using the cosine rule, QR squared is equal to 175 squared plus 242 squared, and you go to minus 2 times 175 by 242 cosine of the angle opposite to QR, which is 82. Again, you just plug all this into your calculator and your calculator will give you 77401.03835. To get QR, you are simply finding the square root, sorry about that, of this very long number. I'm just going down with it there. So QR is equal to 278.2 kilometers, right? Now they did say, they said the distance to the nearest kilometer. So that means like to the nearest whole number. So therefore you will put QR is equal to 278 kilometers. And we're going to write that in. QR is 278 kilometers. All right, in case we need it for our next part of the question. Let me just change the color. Okay, so we are now on part 3. Part 3 said, calculate how far due south is ship R off the harbor H, right? So how far due south is the ship R off the harbor H? So starts from H, how far due south is the ship R of the harbor H, right? So you're going to draw due south, south. Well, we all know what is north, south, east, and west. So we know this is north, this is south, this is west, and this is east. Okay, so this cannot be south. Okay, so south has to be straight down. We come straight back across like this, right? And this is what we want to find. How far due south is ship R of the harbor H? So we want to find here. So let's call that X. This here is a right angle triangle, and we want to find X. We know that this here is a straight line. If this is a straight line, all the angles add up to 180 degrees. So to find this missing angle here in blue, 69 plus 82 from 180 will give this answer, because this whole thing, 1, 2, 3, should add up to 180 degrees, because all the angles in a straight line adds up to 180, right? So 180, take away the 69 degrees and the 82 degrees will give us this missing angle, and that will be 29 degrees, okay? We want to find this side. We have hypotenuse. The right angle points at the hypotenuse. And what else we have? This is the side we want to find. The angle points at the opposite, so the remaining side is called the adjacent. We have adjacent and hypotenuse, so we know it's cos, right? So cos theta is equal to adjacent over hypotenuse. Just in case you didn't know, what did the pen go? So it's so katwa. If you need help, then just type that in the comments. So sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan is opposite over adjacent, okay? So cos of theta, which is 29, is equal to the adjacent, which is x, over the hypotenuse, which is 242. You simply cross multiply, so you get x is equal to 242 cos of 29. When you when you plug this into your calculator, 242 cos 29, the calculator will give you 211.7 kilometers. All right, so that's your answer. All right, so that's it for the May-June 2021 paper question 9B. So let's continue. This one is the January 2021. Okay, we are on bearings. The topic is bearings. So let's see what the question says. From a harbor H, so from H, the bearing of two buoys, S and Q, are 185 and 311. So they only give us the 185. We have to determine where the 311 goes, respectively. So let's see. So from a harbor H, the bearing of two buoys, S and Q. So from H, we are going to S. So S seems like it got cut out. So this point here is S, okay? So from H, our north sign, we are going to S, and then we are going to Q. Okay? Now they said S is 185, Q is 311. Okay, so it's S and Q respectively. So S goes first and Q goes after. So here, all the way to S is 185. And then all the way to Q, this whole thing here is 311. If this whole thing here is 311, and we know this portion is 385, obviously, right, this missing angle in there is 311, take away 185, because this whole thing is 311. Remember, from H all the way to Q, right? Remember, Q is 311. From H all the way, from the North Pole at H all the way to Q gives us 311, right? And part of it is 185, so this missing angle is 311, take away 185, which gives us 126 degrees. Insert the, okay, let me read that. So on the diagram below, which shows the sketch, I totally forgot this part. So Q is 5.4 kilometers from H. Q is 5.4 kilometers from H. Where is H? This is H and this is Q. So Q is 5.4 kilometers from H, while S is 3.5 kilometers from H. S here to here. So S from H is 3.5 kilometers. Right? So this length here is 3.5 kilometers. On the diagram below, which shows the sketch of this information, insert the value of the marked angle Q QHS. So the angle is at H. And that's what we did, right? So QHS and the angle is at H. We already worked that out. Part 2, calculate QS, the distance between the two boys. So QS, that's here. All right. So give you a minute to think. What do you think would we use to find the missing length? Dun, 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 dun. I hope you got it correct, right? So it's the cosine rule. All right, so QS squared is equal to the other two sides squared. I don't know if you noticed this, but the other two sides usually make up they join to make the angle. So these two lengths join to make the angle that's opposite to the length we're going to find, right? So that's 5.4 squared plus 3.5 squared. And we are going to subtract 2 times the 5.4 times the 3.5 cosine of the angle opposite to the length, which is 126. So again, I just put all that in my calculator. So that's 63.62828254. QS is equal to the square root of that really big number, right? Again, if you know how to store this number and just find the square root of the previous answer, that will save you a lot of time. So QS is equal to 7.98 kilometers. So we just worked out this here to be 7.98 kilometers, right? Now part 3, calculate the bearing of S from Q. Let me get another color. Part 3, calculate the bearing of S from Q. So the bearing of S from Q. So from Q means you're starting at Q and it's a bearing. So you have to put your north pole. So from Q, you're going all the way to S. So this is the angle that we want to find. Okay. Now remember, this angle plus this angle makes up 180 degrees. Could we find this missing angle? We can, because we have here and here. So it's just simply add this one. Well, actually, we have this whole thing. We knew this whole thing was 311, right? The 185 plus the 126 makes 311. All right. And the rest would have make up the 360, because the whole circle, the total amount of degrees in a complete circle is 360 degrees. So to get this missing angle, you simply take the 360 degrees and you are subtracting your 311, which gives you a total of 49. So this angle here is 49 degrees. So since this angle is 49 and these two angles add up to 180 degrees, this angle will now be 180 subtract 49, because these two angles make up 180 degrees. Okay? When you subtract those two, you will get 131. Yes. So this angle here is 131 degrees. Okay. Now we just need to get this missing angle. If we could solve this missing angle, we could just add these two angles together. Now, what do we do to find the missing angle in a triangle that's not a right angle triangle? We use the sine rule. Okay, so we know this length. So the length is 3.5 divided by sine of the missing angle. So let's call this missing angle x. So the length 3.5. So we are on part 3. Okay, the length is 3.5 divided by sine of the angle that's opposite. So that's x is equal to your we have this angle here and this length. So the length of 7.98 divided by sine of the angle that's opposite to this length, which is 126. You simply do your cross multiplication, your algebra, and you make x the subject of the formula. So 3.5 times sine 126 is equal to 7.98 times sine x. Right? You're making x the subject of the formula. So sine x is equal to 3.5 sine of 126 all over our 7.98. So x is equal to, when you bring across your sign, you get sine inverse of everything you had, which is 3.5 sine of 126 all over 7.98. I know this was written kind of very close, but it's the same 126 we bring it down, okay? So when you plug all that into your calculator, you can literally put all this in your calculator. Again, if you need help using a calculator, just type that in the comments below, okay? So we have 20.8 x's in degrees. Wonderful. So we got x to be 20.8. Remember, it's not x we want, eh? Well, yes, we want x, but that's not the final answer. The final answer is this whole angle here, right? So the bearing of S from Q, so you have to make a little note. So the bearing of S from Q will be, well, x, which we worked out to be 20.8. And you have to add that to the 131 degrees. When you add these two values, you are going to get 151.8 degrees. All right? Easy, 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 easy. All right? Basically, all the questions are pretty similar. All right? So let's see what we have next. We are now on the January 2020 paper, question 6 part B. Now, this again is not a bearings question. All right, this should really be in another YouTube tutorial, but we'll do it one time, okay? So the diagram below, not drawn to scale, shows triangle MNP. So we have MNP, right? In which angle MPN is equal to angle oh gosh, I said the wrong thing. So let me start over, right? So the diagram below, not drawn to scale, shows triangle MNP, cool, in which angle MPN, so the angle is at P, right, is equal to angle PMN, right? So they actually put at 52 and 52. And MN is 12.5. MN is 12.5 centimeters. State the type of triangle shown above. Well, of course, if you have these two angles here are equal, you know, for an isosceles triangle, the two base angles are equal. So for part 1, it's an isosceles triangle, right? In an isosceles triangle, right? If you draw an isosceles triangle, these two angles here are equal. No matter however you draw the triangle, once these two angles are equal, right, it's an isosceles triangle. Part 2, find the value of angle PNM. PNM, oh gosh, that's so simple, right? All the angles in a triangle is 180 degrees. All angles add up. So to get that answer is 180. Subtract the sum of the other two angles. 52 plus 52. All right, and that will give you 76 degrees. So this angle here is 76 degrees. And part 3, calculate the area of triangle PN, the angle of the, calculate the area of the triangle MNP. These, the M and the N, I'm twisting up my tongue. So MNP. So MNP, we want the area of the triangle. Now we know that the area of a triangle is based by height times 2, but we cannot use that in this case. So we're going to use the next formula, which is a half AB sine theta. So that's a half. Now A and B are the two lengths where theta is between. Okay, so let's say we are using theta as 76. All right, A and B would have been these two lengths here. Okay, now in this question they told us that the base angles are equal. Okay, now since the base angles are equal, these two sides are also equal in an isosceles triangle. So this side is equal to this side is equal to this side is equal to this side in an isosceles triangle. Okay, so since here is 12.5, this length is also 12.5 centimeters. So it's a half of 12.5 times 12.5 sine of theta. Theta is 76 degrees, the angle between the two lengths, okay? So that's 76 degrees. So that gives us 75.8 centimeters squared. All right, simple. Moving on, January 2020, question 9B. Same year, but now we're on question 9B instead. All right, the diagram below now drawn to scale shows the route of a ship cruising from P to Q. P to Q, and then to R. The bearing of Q from P is 133. They told us what they showed it in the diagram. And the angle PQR is 56 degrees, and they showed it for us. We don't have to insert anything. They, however, want us to calculate the value of angle W, right? So this is W here. So this is W, and we have to calculate this angle. We know that this whole thing here is 180 degrees. Right? Now, if we could find this angle, we could find this angle. Now, these two angles here add up to 180 degrees, right? From our previous questions. So therefore, 180 degrees subtract the 133 will give us this missing angle, which is 47 degrees. So to find for W, all right, W will be 180 degrees. And we are now going to subtract the 47 and the 56, right? 47 and the 56. So that will give us W as 77 degrees. Part 2, determine the bearing of P from Q. Determine the bearing of P from Q. So it's of P from Q. So you're starting at Q. Let me change the color for you to see that. So you're starting at Q because it's from Q and you're going to P. So you're starting at Q, you draw your North Pole, and you're going all the way around till you reach the line that connects to P. So we need to add this angle plus this angle. Now everything is literally laid out there for us. We just have to add them all together. So the bearing of P from Q. So the bearing of P from Q will be 180 degrees because in a straight line, the total amount or the total number of, or the total value of the angle is 180. You're adding it to the 77, which we calculated, and then you're adding the 56, which they gave us, right? All in degrees, 180 plus 77 plus our 56 gives us 313 degrees. Now for the last part of the question, part 3, calculate the distance RP. RP, right? We want to get this distance here. Well, we know we're going to use the cosine, right? So RP squared is equal to these two these two sides, 210 squared plus the 290 squared. Again, this is the side we want to find, so we're going to use the other two sides, and the angle between is usually opposite to the side that we want to find, okay? So we're going to minus 2 of the same two values that we had there. So the first one squared, the second one squared, minus 2 times this and this. Cosine of the angle opposite to RP. The angle opposite to RP, or I should have said PR, but anyway, RP is 56. You plug all that in your calculator, you're going to get 60090.30436. So RP is simply the square root of all of that. And your calculator will tell you it's 245.1 kilometers. So RP is 245.1 kilometers. Okay, so let's move on. June 2018. Sorry, question 9. We are actually almost through. I believe this is the last question. Yes, it is. This is the last question for this tutorial on bearings. I will upload some more tutorials with some more trigonometry, such as angles of elevation, and then some regular trig questions with SOHCAHTOA. All right, and we have some more bearings to do as well, so I will upload another tutorial. Okay, so we are on the May June 2018 question 9b. The diagram below now drawn to scale shows the relative positions of three reservoirs, B, F, and G. Let's identify them. B, F, and G, all on level ground. Okay, the distance BF is 32 centimeters. Okay, FG is 55. Okay, angle BFG is 103. B, okay. BFG is 103 and F is on a bearing of 42 degrees from B. So F is on a bearing of 42 degrees from B. Okay, so they gave us everything. They just wrote it on top there for us to know. Determine the bearing of B from F. So from F, we're starting at F, okay? So determine the bearing of B from F. We're starting at F, so put your little north pole. We're starting at F and we're going to B. So you're starting at F and you're going all the way around until you reach the line that connects to B. All right, now we know this part of the angle. If we can get this missing angle here, we are good to go. Okay, all right, so let's see what we can do. This angle and this angle adds up to 180. So let's put that in and see if that will help. All right, so to get this missing angle is simply 180 take away our 42. 180 take away 42 will give us 138 degrees. Hey, and obviously it's helping because now this is the only angle that's missing and the whole thing adds up to 360 degrees. So 360 degrees, take away these two angles, which is 138 and 103, will now give us our missing angle. All right, so 360 take away these two angles will give us 119 degrees. Yeah, and that's the angle as the answer. So part one, right, the bearing of B from F, I should say, sorry, is equal to, you could actually put that down, I just rewrote it. So that gives us what? 119 degrees. Oh no, you have to add all. Oh gosh, sorry about that. Okay, let's just erase that. Let's erase that. We have to actually get the entire thing. What I mean by that, the bearing of B from F, right, is what I said at first. So the bearing of B from F, so you're starting at F and you're going all the way around to B, right? Once you're paying attention, you would have heard me say that. You're starting at F and you're going all the way around to B. This is the angle we want to find, right? So it's 119 plus the 103. So the bearing of B from F will be our 119 plus 103. I hope I did not confuse you there. If you're not, you can just rewind because I said it in the beginning, right? The bearing of B from F. So you start at F and you just continue. So you're starting at F, so you draw a north pole, and then you go all the way around until you reach to B. And you're going to add these two to get this angle in red. When you add these two, you will get 222 degrees. Okay, so that's part one. Part two, calculate the distance BG, given your answer to one decimal place. BG, that's this here. You know what rule you have to use by now. If you have reached this far in this tutorial, you know the rule already. Okay, just a matter of applying it. So BG squared is equal to the other two sides squared. And you're going to subtract 2 of the same two sides. And then cos of the angle opposite to this. So it's BG, the angle opposite is 103. You plug all that in your calculator, all right? Just like that, no matter the calculator using, you can plug that in. Well, once it's a two-liner, has to be a two-liner, right? And then BG is simply the square root of that very big number, 4,840.8278. All right, so BG, you will get 69.6 kilometers. Okay, moving on to part 3 now, which is the final question in this tutorial. Right, we have done very well. We've done good. So calculate to the nearest degree the bearing of G from B. Calculate to the nearest degree the bearing of G. So it's of G from B. Okay, from B. So just you have your north here. So it's from B and you're going all the way down to G. So we just need to find out this missing angle and we can add these two angles, okay? Now, how do we get the missing angle again? Well, we know how to do that by now. We're going to use the sine rule. Okay, so this is the angle we want to find and this is the length opposite. So 55 over sine of this angle. So just call that angle B, right? You can call it anything. You can call it X if you so desire. So 55 over sine of the angle at B is equal to, we just worked out this here. This side, we worked it out to be 69.6. So it's equal to the length, which is 69.6 over sine of the angle that's opposite to that length, which is 103. You simply cross multiply as what we were doing before. So 55 sine of 103 is equal to, so 55 times sine 103 is equal to 69.6 sine B. 69.6 sine B. All right, so I am running out of space. So sine B is equal to 59 sine 103 all over 69.6. Remember what I have been saying, okay? You could like work out this answer, so you'd have had an answer here. All right, and then it would have had less terms in the bottom here if that's more comfortable for you. All right, it's however you feel comfortable doing algebra. Okay, so B is equal to sine inverse of this really big number, right? Algebra is like one of the foundational topics of math. Without algebra, all else fails. All right, so I tend to spend a lot of time in algebra when I am teaching my students. Okay, so it's sine inverse of 55 sine of 103 divided by 69.6, and that will give you 50.4 degrees. So this angle in here is 50.4 degrees. Remember, we are not done, right? Like in the previous question, totally forgot to do it, and then we did it after. So the bearing of G from B, right? So write a little note. The bearing of G from B, right, will be the 42 degrees, and you have to plus what you just worked out, the 50.4 is this angle plus this angle to get the whole angle. When you add those two, you will get 92.4 degrees. All right, so it was really nice. Thank you guys so much for tuning in to my YouTube channel with my bearings session. All right, we did cover from 2018 to 2022, the January and the June papers. So that's like a good bit of years. I will try to do some more questions on bearings, but that will not be my next tutorial. I'm going to try to do some angles of elevations, angles of depressions, all right, as well as some regular tricks questions. And we are going on to some other topics. All right, so remember, if you did not subscribe, please subscribe below, like and share this tutorial. See you soon. Bye for now.